Growing up, I was pretty nerdy. I loved computers, games, and comic books. When I first started out programming, I wanted to make games. I made my first game ever when I was 10 years old based on my favorite comic book, Green Lantern. The game was really simple. It was a text-based game where you were presented with a choice. If you made the correct choice for our hero, he'd continue in the game. Make the wrong one, Green Lantern died. If you got past all three choices, you won the game. The full game used simple print statements and the if-then statement. This is what I'm going to show you next. The goals for this lesson are to understand the if-then-else control statement. As we have in past lessons, we'll look at ways that code can go wrong. This way you know how to identify the errors in your code when they happen. We'll touch upon short-circuit evaluation, and when we're done looking at the normal if-thens, we'll quickly look at the very succinct ternary version. Now that's great for setting single values without writing the whole if-then. So let's dive in. An if-then is a Java control statement that behaves exactly how it sounds in English. If the statement is true, then do this. The if-then has a keyword and condition. The keyword if starts the control statement. It is immediately followed by the condition to test. The condition is always enclosed in parentheses. It's an error to try to create the if-then without parentheses. If your condition is true, the Java block is executed. False, and the Java block is skipped. We can test if power is greater than 5, shoot the bad guy. Power is less than or equal to 5, then the code won't run. The condition can be a boolean expression or boolean variable. The only requirement is anything inside the parentheses must evaluate to either true or false. If you're coming from a C background, it's important to note that the condition does not evaluate to 0 or 1. It must be a Java Boolean type. Since it can be a Boolean expression, you can do something like this. If ring is charged is true and the power is greater than 5, run this block. Both conditions must be true. It's a good idea to use parentheses inside the condition expression to make this clear. Larger conditions should be compressed for readability. You can create a Boolean value from a complicated expression and then just test the value. In this case, we're creating a variable called myCondition and setting it to the result of the expression. Let's play with if-then statements so we can get this idea clear. Okay, here in our code, I've created a variable, power, and set it equal to 6. I've also got a condition where power is greater than 5. Now, if power is greater than 5, which it is since it's 6, we should see this line printed out. Power is greater than 5. So we run it, and it prints out power is greater than 5. Let's go back and change power equal to 4 and see what happens. In this case, 4 is not greater than 5, so it should not print out anything. We run it, and nothing's printed out. Okay. What do you think will happen in this case when power is equal to 5? Well, we run it, and nothing's printed out again because power is not greater than 5, it's just equal to 5. Let's go with the case where we want to check if power is equal to 5. Say, for example, we have some case where it'll only run when power is 5. We would test that, as we saw in the operators video, with the double equals. We run it, and it printed out power is greater than 5, but really the test was is power equal to 5. Sometimes we want to say, if something is true, do this. Otherwise, do something else. We have that ability in Java. We can add another keyword called else. In this example, we are saying, if power is greater than 5, then do this Java block. Otherwise, do this other Java block. You can also chain these into longer if-then statements. For example, this block tests if power is greater than 5 and tests if power is less than or equal to 5. This is really the same thing as the else statement from before. We're just making a second test explicit. If you use this keyword else without a condition, it will run the following code block if all other ifs are false. You can add as many else ifs as you need as well. Just don't go crazy, or it gets really hard to read. So what happens when not everything is accounted for? For example, In this case, there's a block for greater than 5 and a block for less than 5. What happens when power equals 5? Well, this just means that both code blocks are skipped. Nothing is run. This illustrates the importance of checking all of your boundary conditions when working with numbers and inequalities. If you are ignoring the equals case, this would be a really good place to add a comment explaining why. Otherwise, you're going to forget, or somebody else looking at your code is going to be very confused by your error. Okay, going back to our example, let's have a second Boolean value. Let's create a second Boolean value, my condition 2, where power is less than or equal to 5. We can create a second test, that is, if my condition 2, then print out power is less than or equal to 5. Now we really don't need to do this. We won't necessarily need to be doing a test for every condition that we want. In this case, there's only two possible options. It's either greater than 5 or it's less than or equal to 5. So we can replace this second test with an else, and it'll result in the same thing. So in this case, my condition is true, it'll print that power is greater than 5. If it's false, then it'll print out power is less than or equal to 5. And it has the exact same effect as the code with two if-then statements. Now this example does greater than, and then it does less than or equal. What if we wanted one case for each? One case for if power is greater than 5, one case for where power is equal to 5, and then one case where power is less than 5. Well, we can replace that code with multiple if-then statements. So, in this case, we have it if it's this, otherwise if it's this, otherwise if it's this. You can create really long if-then statement chains, but it's considered bad practice, and there's probably a better way to do it if you find that you are testing and have a case for more than 4 if-then statements. Another common source of errors is forgetting to use braces. As we saw early in the blocks lesson, a statement can be a block. Still, you want to use braces. Here's a good example where you might not get the behavior you're expecting. In this example, removing the braces means the second line will always be printed. The indentation is ignored. Just going back to the IDE, we can see this problem in action. So this code is similar to what we saw in the blocks lesson, where you can create a Java block without the braces. However, if you don't include the braces, it makes it kind of weird. In this case, we have if power is greater than 5, print out power is greater than 5. And the next line we have power is less than 5. Now, if the code was indented like this, it's going to be confusing for someone reading it. They're going to look at this and think that these two lines are part of the same Java block. So when we run it, it prints out power is less than 5. We might have expected that that particular line was part of the power greater than 5, and we'd be really confused on why that line ran. The reason is power greater than 5 is its own Java block. We really should be putting in braces to be really clear what we intend to happen. Sometimes you'll have a test that takes much longer to evaluate compared to the other tests. For example, you might test if 5 is somewhere in a list of a million numbers, and test if b is larger than 4. The test for b is much easier and quicker than searching through a list of a million numbers. If both need to be true, always test the easier test first. In this case, it would be much better to switch the Boolean test. This works because of short-circuit Boolean evaluation. This means it will stop evaluating the Boolean expression if it knows it will evaluate to false regardless of the rest of the expression. Since both need to be true, there's no point in searching a million numbers if b is not greater than 4. So if b is 2, Java won't even try to search. When you need to set a value based on a Boolean expression, there's a much simpler code than the full if-then. This is called the ternary operator. It's an operator we didn't cover in operators because, well, this operator is a control operator and we really hadn't covered what that meant yet. We can write it in a one-line statement. You simply set your variable to an expression. The first part is the expression to test. Next, we use the question mark to note that this is an if-then test. Finally, we put the two possible values separated by a colon. If the condition is true, the variable is set to the first value. Otherwise, it's set to the second value. There are no possible ways to handle an else in this expression. Let's go play with this in the editor. The last thing to look at is the ternary operator. So if we had a variable b that we wanted to set, and we wanted to set it to 42 if power was greater than 5, and 24 if it was less than or equal to 5, we could write that all in one line. We don't have to do a full if then. In this case, we have our ternary operator where power greater than 5 is our condition, and then with the ternary operator, we'll set it to 42 when it's true and 24 when it's false. Now, like with other conditions, we can also replace our power greater than 5 with the actual condition. When we run it, in this case, b is equal to 24. Since power is equal to 5, it's not greater than 5. Again, it's important to note that you cannot handle an else condition here because you can only have two possible values. There, you can't chain with multiple colons or with some other syntax to say if then else. It's always if it's true, the first condition, false if it's the second condition. There are ways you can really abuse the if then statement and create some obnoxious code. For example, you can create this if then code to set a boolean value. This is bad code. The reason is this is 6 lines of code all to set a boolean value. Can you guess the better form? I'll give you a hint. It's not the ternary operator. This is what you should do for booleans. In this case, the boolean expression you're evaluating is a boolean value. Instead of using an if then to do the logic, just set it to the value and you're done. The best code ever is the code that you don't write. So in this lesson, we learned about the if then statement and how we used it to control what code is run in our application. We learned how Java will short circuit your conditions and how this can speed up your program. We also learned about the ternary operator. And with that, I will see you in the next lesson. Hey, thanks for watching the video. There's a quick quiz for this on dg.com if you'd like to gauge how much you learned. If you like the videos you're seeing, please let me know by liking the video and hitting the subscribe button for the DG channel on YouTube. I'd really appreciate that. If you have concerns or questions, please leave them in the comments below or on dg.com. There's a poll on the front page of dg.com, so you can also let me know what topic gets covered next. Thanks for watching and see you in the next video.